So we're looking at example 1 today, and we're finding the resultant of forces acting along an inclined plane. So the question here says find the magnitude and direction of the resultant of the forces shown below. So we're looking at this diagram here, and we have an inclined plane at the angle of 40 degrees, and we have three forces acting on this particle here. Okay, so we've got 26 newtons pulling it up along the plane, we've got 58 newtons acting perpendicular to the plane, and we've got this 84 newtons which is acting not perpendicular but at an angle to that plane there. Okay, so what we're going to do is we're going to find put all their forces into this diagram here, and we're going to find the forces, this time not horizontally and vertically like we've done before. We're going to do it along the plane. Okay, so going along the plane and then perpendicular to the plane. Okay, so along the plane and perpendicular to the plane is what we're going to do. So we're going to mark these on over here. Okay, so let's start off with the ones that are more straightforward. So 58, well, perpendicular to the plane, that's 58 newtons. So that's just going to be just your 58. Parallel to the plane is just 26. Now this one here, 84. 84, we're going to have to work out an angle here. So what I want you to just look at is if we made this a triangle, just extend this line down, this would be a right angle. This is 40, so this would leave this angle here at 50. Okay, if this angle was 50 and then I created this perpendicular to the plane, this line going down, obviously create 90 degrees. If this is 50, this would be 40, and that's the angle we're going to use. So the quick way each time is whatever the angle is here, by using just angle properties of a right angle triangle and 90 degrees getting this, it works out that the angle that's here is always the same size as the angle in here. Okay, so I'm going to take this force and I'm going to split it into its two components. Normally horizontally and vertically, but this time it's going to be perpendicular to the plane and parallel to the plane. Okay, so I'm using the angle of 40. Okay, so for this one here, it's going to be 84 and then cos of 40, because remember we talk about the included angle, so I'm using 40. You can ignore this 50, we're just going to use the 40. Okay, so 84 cos 40 is down here, and that means when we split this up to the parallel to the plane, it's going to be 84. The 40 is not included now, so it's going to be 84 sine of or angle of 40 there. And that is all the forces now. We've got 58, 26. This is the one force needed split. We split it into two parts, going perpendicular to the plane, 84 cos 40, and parallel to the plane, 84 sine 40, and that would take it then going down. So we've got our forces parallel and perpendicular, and we're now going to use those there. So what we're going to do is we're going to work out the resultant force along the plane. So we're talking about going along the plane, okay, and I'm going to take that as going up the ways for that way there. So the force is going to be going up the ways, 26 going up the ways, and again I'm just going to leave these here. I'm not going to get the value worked out for them yet. So 26 going up, 84 sine 40 is going in the opposite direction, so we'll have to subtract then our 84 sine 40. I'll work that out in a little moment, and that is going to be our resultant force along the plane. I am now going to work out the resultant force, and this time it's going to be perpendicular to the plane. But we have all these in this diagram here, so we don't have to really refer back to this. We have them all here. So perpendicular to the plane, and I am going to do those going up the way. So perpendicular, I'm just going to do a little right angle to mean really perpendicular going up the ways. Okay, so I am going to do 58 going up perpendicular to the force, and this is going the other way, so it's going to be take away 84 cos 40. Now let's work out those two forces. So the first one there should work out as minus 27 point, it's 994, so we'll take it as 27.99, and the other one there 58. Now because it's a minus 27.99, we had done this going up the plane, that means that really it must be acting down the plane there. Okay, so that's going to equal 27.99, and it's going down the plane. Okay, because obviously it's a stronger force pulling down the plane. The negative just indicates that. Okay, and that's because I chose to do it up the ways. For this one here, we should have 58 minus 84 cos 40, and that will give us there minus 6.347. So I'm going to round that to minus 6.35. So I'm just going to round those both to 2 decimal places. Again, I done this perpendicular going up. It's ended up negative, so obviously it's going to be a positive force going down the way. So obviously this one here is a stronger force, and it's actually pulling in this direction. So I'm going to write that as 6.35, and just to keep myself right, I'm going to say that it's perpendicular, it's going down the other way. So it just means it's going down that way there. Okay, now we're going to then work out or magnitude, find the magnitude and direction of this resultant force. So I'm going to draw the resultant forces in a diagram. So draw the resultant forces. Okay, now I've got 27.99 going to the left. You can draw it at an angle if you wish. Well, maybe you can draw it at an angle or just go on that. We'll draw it at an angle just to keep it the same. I suppose we'd say it was going parallel to the plane there. So that there is 27.99 was acting down the plane. Okay, and then the 6.35, that was going then this direction here. So 27.99, and then this one here is 6.35. Okay, and these are just newtons. So we've got our resultant forces. Parallel to the plane is 27.99, and perpendicular to the plane is 6.35. Go back to the start and draw our resultant force of this, and that is marked in as a right angle. Whoops, move that up for you there, sorry. Mark that in as a right angle, and now all we have to find is this resultant force. So we're going to use Pythagoras theorem. R squared is 27.99 squared plus 6.35 squared. So R will just be the square root of all of that. So R is going to be 28.70, which we will round then to 3 significant figures, 28.7 newtons. That's a resultant force. We now want to find the angle at what this resultant force is acting on. So we're going to use our tan, and remember this here, because this is the parallel to the plane. If you look here, move that down a bit for you. So we've got the force acting parallel to the plane, so you want the angle. So if we move that up, we're looking for this angle here. I'll just call that x. So it's resultant force is acting on the plane, but what angle is it acting there? So we're going to find our angle, and that's going to be tan of x, and we're just using your O and our A that we've got there. I'm not going to bother with this one here. So it's going to be tan of x is the opposite of 6.35 over 27.99. Obviously we're going to just do tan to the minus 1 of that, and that will give us there, with our calculator, it should be 12.782 and so on, and we'll round that to 12.8 degrees there. So we can write that, what have we got here? We were asked in our question at the start to find the magnitude and direction of the resultant of the forces shown below. We have now got the resultant of the forces, and we have the magnitude and direction. So we can say a force, you can see that, yeah, a force of 28.7 newtons acting at 12.8 degrees to the plane. Okay, so that is the first example. Now that is the same example that's in the textbook, but I have just worked it through for you there. Okay, so you can pause that and record it down, and you can refer to the textbook as well.